All right, so first thing is I want you to pay attention to the couple things. So all right, so we're gonna talk about why inverse sine graph. So inverse sine graph is not hard, but I just want you to understand the reason. But there was one specific graph I use in BC a lot, so I need to talk about that specific graph. But inverse sine, inverse trig, normally you do not need to memorize that graph, but it just inverse. Do you guys remember inverse function look like? If you have one function, what would be the inverse of that function graph look like? X and Y swap, good. So let's just say if I have a graph looks like, just to remind you, see if you guys can find it. So I have this graph here. And is it possible to find the inverse graph? How do I find the inverse graph? Told me what to do. How do I find, this is the f of x graph. How do I find the inverse graph? Huh? No. Huh? Switch the x and y. Good. So here it's going to give you -3 and 1, right? So it'll be 1 and -3. Does that make sense? And this is a -1, 2. And that's going to be 2, -1, right? And this point, actually, I'm just going to take this point. So that's going to be 6, or 3 and 6. And it'll be 6, 3. And this is the graph. Right? Now, wait, hold on a second. I think I made a mistake. -3, 1, -3.
What's the third dot? Like if the x up there.
Hold on, I just want to make sure I did it right. 1, 2, 3, 4, 5, 6. Did I do it right? Looks off. -1, 2. I feel like this is off because slope should be 1. Oh, this is 3. Yeah, that's so it should be 3. So it should be here. And now this is correct. The reason why they have symmetry of this line, right? They have symmetry. So, and this is y equal to x. And this is how you find inverse function. But before you can have inverse, you must have a certain requirement in order to have an inverse function. Do you guys remember what's the requirement to have an inverse? Do you guys remember what's the requirement to have inverse? Yes. No. What's the requirement for the function to have inverse? Yeah, you're talking about the verifying part, but no, I'm talking about in order for you to have an inverse function, you must pass certain tests. Horizontal line test, thank you. So in order for you to have inverse, first thing you must have monotonic monotonic, either it's increasing or decreasing. That means a function can go straight up or go straight down. You cannot go up and down. So a parabola cannot have an inverse function. Parabola cannot have an inverse function. Monotonic can be also talked about is strictly increasing or decreasing, or probably easier way to think about it is pass horizontal line test. Pass horizontal line test. So monotonic is a key word. Monotonic means it's only one direction. It's just going up or going down, but it's not going up and down. So a parabola go down and up. Can you have inverse function of that? No. But you can do is cut the parabola to half. If you cut a parabola to half, then you'll be going up only or going down only. Then you can have inverse function. So you can have apply a certain restriction. Yes. First words. Monotonic, increasing or decreasing. So monotonic means one directions. Strictly increasing, decreasing, that's just another addition part, but it's past horizontal line test is the second part. Now you realize that a parabola cannot have an inverse function only if I cut a parabola to half. So if I have a parabola like this, so if I have a parabola like this, I cannot have an inverse. However, I can do is I can take an eraser, says, hey, let me do this. Now I can have an inverse function. And so that's how you have inverse. So I spent a lot of time to talk about a kind of like not important. But what I'm trying to get to is, can sine function have inverse function? If you cut it, but how do you cut sine function? We already know how to draw sine function. So this is a sine function. It start at 1. It go here, it go here, it go here, it go here. Oh, sorry, this is cosine, my bad. Sine is gonna be here, 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 here. And it's gonna take 2 pi to go through that. Okay, so can I have an inverse function on this? How?
You cut it off at pi over 2 and negative pi over 2.
Hey, good.
Yeah.
That's a very good thinking. You cut off because here is pi. It has 2 pi actually. This is pi. This is pi over 2. And this is pi over 2. And this is pi. And this is 3 pi over 2. And this is 2 pi, right? So what you can do is you can cut off, you can start erasing this side. And we're going to start erasing both ends. We're going to start erasing both ends. And then we say, hey, this is a pass horizontal line test. As of right now, is it passing or no? No, it will fail, right? You'll fail here miserably. So therefore, you have to cut more. And if I cut, I'm going to cut all the way to here, like what Alex says. And I'm going to cut here, like what Alex says here. So now I can say only negative pi over pi over 2. And guess what? Now this function can have inverse. So you can plot this graph, and it's probably going to look at something like this on the other way, and that will be your y equal to sine inverse of x graph, because they have that symmetry line right here. So you're going to have the other way. Okay. So this is the inverse sine graph. So if I want to go back and I'll say, hey, I want to erase this graph, basically it's going to be the green part of the graph. So let me zoom in a little bit. It's going to be a green part of the graph. And it's cut off negative pi over 2 and pi over 2. That's why remember, we asked you what is inverse sine. Sine inverse of negative half. What is it? Let me ask somebody. Gabby. Gabby, what's sine inverse of negative half? That's a great question. Phone a friend. Phone Luke. I'm just kidding. What is sine inverse of negative half? It's okay. If you got it wrong, we're just gonna... Huh? Almost. Negative pi over 6. Because pi over 6 is going to give you 1/2. Negative pi over 6 is going to give you negative 1/2. So do you realize the output is always going to be between negative pi over 2 to pi over 2, which is the right part of the unit circle. And this is why sine inverse that has this part of the graph. Now, I'm not very big about memorize sine inverse graph and cosine inverse graph, but cosine inverse graph, this is another issue. So if you have a cosine graph, how would I cut it off where you can pass horizontal line test? Like, how would I cut this graph into where you have horizontal line test? And this is a, this is a pi, this is 2 pi, this is a 3 pi over 2, this is a pi, and this is a pi over 2. And if I cut it from both ends, you're gonna realize it doesn't matter if I cut it from both ends, you're still gonna fail horizontal line test, because at this, I'm still gonna fail, right? So that means I cannot cut it from both ends. That means I had to cut it from here, and I just focus on one end first, and I'm start cutting from the other side. So I'm gonna take an eraser, I'm gonna cut this. I'm gonna cut this. And yeah, so this will be a 0 to pi. And that's why cosine inverse has a domain, the input, you can only put, the output can only be 0 to pi.
Could you use like the other side?
You could, but we just want to strict between 0 to whatever. So that makes a lot easier. So if you see this, then you say, oh, okay, well, that makes sense. So what I'm going to do is I'm going to talk about the last one. Now, the inverse of this graph is going to look kind of weird. It's going to look like this, because they're going to swap. So it's going to look like kind of like this. I'm going to try my best to graph. You don't have to really know this graph, but it's going to be something like this, because it's going to reflect to this line, and the scale is going to change a little bit. So because it's going to be built up to the other side. Okay, so it's going to be the purple part. So this is the cosine inverse graph. I just feel like I need to talk about those, but it's not really on the test. Okay, it's not really something that I'm going to be a test for a lot. Yes.
Why cosine inverse? Like, why does the line go up? Why does sine just go the other way?
Because they reflecting to y equal to x. They use this as the line to reflect. You have this, right? The other one is going to be this way. So it's going to reflect toward over that y equal to x graph. And that's why the graph's going that way. Now this one is like not really often, but I do want to talk about the last one. Is the tangent graph. I didn't really put it on the last test, the tangent graph, which is, I feel like a lot of you guys still scared about tangent. But pi over 2, negative pi over 2 to pi over 2. And that's going to be an asymptote like this. So this is a tangent graph. Now the y equal to tan inverse graph, it's actually look like this. So instead of horizontal asymptote, it's going to be a vertical asymptote. It's going to be a horizontal asymptote. It's going to look like this. And the graph's going to go like this. Now this graph I need you to know, because this graph, it happened all the time. Not only you need to know something is limits as x approach infinity of tan inverse of x is actually equal to pi over 2. Limits x approach negative infinity of tan inverse of x equal to negative pi over 2. So if I go into the right, this is going to be pi over 2. If I go into the left, that's going to be negative pi over 2. This is going to come back in AB or BC, where you have question that involved with this. Now, normally you just have to be able to find me tangent inverse of negative 1, which is negative pi over 4, or tangent inverse of negative square root 3, which is negative pi over 3. You just have to tell me all the things. But this particular graph, I will say you have to know, because you know the tangent graph and you invert it this way, then it's going to be sideways. So instead of vertical asymptote, it's horizontal asymptote. Sure. So this is a 10 graph, this is 10 inverse graph. The 10 inverse graph, you're going to have 2 horizontal asymptote instead of 2 vertical asymptote. And just invert the graph this way. When it go to infinite, it's going to be pi over 2. When it go to negative infinity, it's going to be negative pi over 2. Especially those of you guys are going to BC, which is, we're going to talk about improper integral that is going to be involved with this. And I just feel like if I don't teach you guys, it's not required on AP pre-calc, but later, then you're going to be like, I don't know, what is that? But this is a basic it. Okay, so this that we finished talking. So this is the only graph that will actually ask you to remember. For the other one, like normally my calculus student don't remember. This is the only graph I want you to remember. Yes. As a limit x approach infinity. So as limit as x approach infinity, also you guys got to read the limits. This go into pi over 2 because it has a horizontal asymptote at pi over 2. As limit approaching negative infinity going to go this way, it's going to be negative pi over 2.
So this is the limit for the inverse?
Yes, only in the inverse, not the original function. That way you know how to read the graph for different situations. With that being said, I just want to emphasize this. I feel like it's important for me later to actually talk about this, and more likely you will forget, and more likely I'll remind you again. So it's not like one of the things that you say you have to know it now, but it's, if I'm talking about it, I'd rather talk everything else. Now the next question is called modeling. We are gonna have to ask you to model certain equations. So this is what this is a test. Oops, let me see if I can find it. This is a test that I usually use to help you. This is a very good test, by the way. This from Canada. Some people don't like Canadian now because we have tariff between today, actually, between Trump and Trudeau. They decided to put 25% tariff with each other. So, you know who's suffering? Everybody else. But, oh well. So now, I'm going to send a picture to show you. Okay, so imagine that you are a person that's sitting on A or B or whatever, right? And I'm going to take a time, and I'm gonna record down what time you are, how high the position is. Now, for you, it's kind of hard to see that, but I will give you a better demonstration. Is if I go to Desmos graph, I log in and continue Google, and I log in my own graph, blah, blah, blah. And we're gonna open the graphing calculator, go back to open up this particular graph. There we go. Okay. Imagine that you're a roller coaster. Now I'm gonna move the K up a little bit because roller coaster is not gonna be on the floor like this. A Ferris wheel is not gonna be on the floor. It's gonna be a little bit above the air, right? Right? Now, if I record the height, so if I take this, if I speed up tiny bit, oops, speed up a little bit more. So I can take the height and I recorded all the height that you have on this Ferris wheel. So I just align it all the way there. See the vertical displacement? I'm going to record all this vertical displacement. It's going to form a general sine graph. Okay, it's going to form a general sine graph. Now you see the midline is at 1.5. I can adjust the midline a little bit to a little bit higher too. I can adjust the Ferris wheel a little bit bigger. How do I adjust the Ferris wheel bigger here? Which number I should adjust? A, B, or H, or K? A, good, because my amplitude. So I can make it bigger for, let's just make it 2 for that matter. Okay, and I'm gonna move up a little bit so because I don't want to hit the floor. Right. I can also increase the periods. Right, so let's change it to 2. What happens if I change it to 2? What will happen? Ooh, faster. Yes, smaller and faster. It's going to be a horizontal compress because your period will become reduced. What the H effect? H probably not too much, but it's your starting value. So it depends on where you want to start a graph here or start a graph here. But H is probably not more. So think about all this element, right? You got impact of A, impact of B, impact of H, impact of K, which is the way I use is A, B, C, D. They use A, B, H, K. So they represent the exact same thing. So now here's the questions. Is it possible I can model this equation of this Ferris wheel with y equal to a sine of b parenthesis x plus k? Is it possible like I can model this? So this is the question I want you guys to think about. Okay, start thinking. I'm not showing the answer. Showing this off the ground 3 feet, and from here to here is 15 feet.
Wait, what was the thing? It was A.
Hey, you want me to write down for you? I'll write down for you. Yeah, of course. So let me write down. Let me split screen.
Yes.
Okay, so now the x-axis is time. The x-axis is time, right? So y equal to a sine of bx plus minus c plus d. So I want you to figure out what will be a, b, c, d here. Now, recognize that we recognize that a Ferris wheel amused has a rider get a position A. So you start at position A, which is 3 meters above the ground. So you get on over there. The highest point is going to be 15 meters above the ground. The ride takes 40 seconds to take a whole revolution. So it takes 40 seconds. Now, I didn't teach you how to do anything. So this is the way you got to use the imagination. Think about what actually happened.
So like, what do you think should higher level? Yeah. What?
Yeah, yeah,
What equals 5 b.
yeah.
Yes, again.
Yesterday you played basketball. He's aim better. He's gonna run out of the thing.
Oh, I missed. Or should I use cosine? Should I use cosine or sine? That's something you can also think about too.
It's the same representation. Different representation.
They use cosine. Because cosine will be easier because you start on the bottom, right? You can't really use sine if you start on that, but that is why you require a shift. Olivia's done?
What I can do, yeah.
Like if it's nobody has to tell the bottom.
Yeah. And then plus 9.
Why not?
Wait, yeah, you're
What
right.
equals 2 pi? What's like 40? 40b equals 2 pi. Yeah, I said 40.
So 40b equals 2 pi.
Yeah.
If you times b on both sides. Oh, wait, sorry. You multiply. I meant, sorry, divide. So 2 pi over
40 equals 2 pi.
Daniela, got it?
What's like 4 pi by b?
Yeah.
40b equals 2 pi. You divide by 40.
This table all got it? Can you help us, Samuel? Does Samuel understand?
Yeah, he got there.
Cassinia got it? Emily, you got it?
Hey, you're not doing this.
Emily and Apple, no? We got it? Okay. So I'll show you the option. I'll show you the option that you guys should have. But which one's the answer? Yeah, is this hard? This is the whole FRQ.
You love.
Yeah, yeah. We'll show you later. But this is the no, 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 this is the. But the thing is, the problem is we have studied so much of understanding how those detail. I just have to show that illustration for you to interact that, because normally that the Desmos graph that can show you, okay, this is what it meant, right? Because it's really hard to form those connections at very beginning. If I just teach you, says, okay, what is this something? So no, I won't say that yet, not yet. Maybe later, but not right now. Right now, it's still underprepared. So I here is A, but I would say we are over prepared for pre-calculus, not college board. That's the only thing I can tell you. But A's right here is on the 3. The between peak and trout, that's gonna be 15 and 3. The midline has to be 15. It has to be 15 plus 3. 15 subtract 3. Sorry, 15 subtract 3 divided by 2, and that's equal to 12 divided by 2. That's equal to 6. Sorry, I did that wrong.
You got it.
Oh, I suppose subtract. Yeah, sure. So I suppose 15 and wait, what's I need to add to the 3. Yeah. So I need to find out the middle. The middle is 15 plus 15 subtract 3 divided by 2. That's equal to 12 divided by 2. That's equal to 6. So we know that is each one is a 6, but 6 is an amplitude. So that is going to give you A is equal to 6. But the midline is going to be right in between. So the midline has to be equal to 9. And that's how you come up with those informations. Now, I hear a very good conversation about people says, oh, okay, well, what is a 40 representing? 40, it just takes the 40 second, you have a whole revolutions. So that means 40 seconds is your periods. So 40 second is equal to 2 pi over b. So b is equal to 2 pi over 40. That's equal to pi over 20. And that's only one D that has that. And why do we choose -6? Because we start at a trout rather than peak. You don't write a Ferris wheel on the top. Okay. I mean, Diego probably can. But yeah, so ideally you're gonna figure out this. And we use cosine because we didn't start writing the Ferris wheel at the middle either. So only if it's on the midline, then we can go in like there. But it's not convenient to write from the middle or the top. It's convenient to write from the bottom. So it has to be -6 cosine pi over 20 t plus 9.
Can you explain the midline again?
And I explained the midline. Okay, so the amplitude is 6, right? Because you take the highest point, which is in this case the highest point is 15 and 3, right? 15 and 3, the you can add them divided by 2. That's gonna be middle. Again, 15 plus 3 divided by 2 is 18 divided by 2 is 9. So you can do it that way, or you can do like the amplitude first. Amplitude is 6. Now, if some number at 6 is going to give you 15, subtract 6 is going to give me 3, it has to be 9. Yes. How do I get 3? Huh? Oh, the period? The period takes 40 seconds. Remember, this is the thing's going to keep a track of everything. So that's take 40 seconds to do a complete revolution, which is 40 seconds represents a period. But 40 seconds is a period, but period for sine is 2 pi over b. So I can do cross multiply 40b equal to 2 pi, and b is equal to 2 pi over 40, and which is equal to pi over 20. And then that's how I got b. Does that make sense? If you understand the idea of this question, you can see FRQ, this is gonna be a lot easier to see, but it just pretty much interpret the actual modeling situation. Now, this could be ocean wave too. Ocean wave is based on the time, sometimes receding, sometimes aboving. So they can record that ocean wave as well. You can do a lot of things. So, for example, there are other situations that you can happen. The clock, right? It takes the pendulum. This is the period as well. So let's look at these questions here. Okay. The pendulum clock swing back and forth in periodic motion. That can be represented by trigonometry function. At rest, the pendulum is 20 centimeter above the base. The highest point in the swing is 26 above the base. And it takes 2 seconds to complete swing back and forth. Let me see, what do they want? They want a cosine.
Because the pendulum when it's they'll get the so you need to add the bit line.
You guys get an answer yet?
Yeah.
What you guys got?
Hey, let's go. Oh. Hey, I was close. I just put it as a negative. Hey, let's go, Sam.
Yeah, but like what? It's like a pendulum. Like a clock.
Oh.
Well, I guess that's bad. Like everything is cool. I'm just saying, thinking about it logically.
Why is it positive?
Doesn't a clock like start from the bottom? Like pendulum?
Doesn't matter. Hello?
I'm looking at it.
I mean, it's still gonna be the same exact function.
Yeah, what is positive?
Okay, but like the pendulum or clock never gets like.
Maybe it's the actual clock. The one above it.
Oh shit, you're right.
Not like the not like that noise thing.
Oh yeah, then yeah, clock starts. Like,
Yeah.
yeah.
Alright, it's positive.
Because the pendulum comes to the circle.
Yeah.
I don't know how clock works.
Is it like the minute hand or something? Yeah.
So you guys got D?
Yeah.
All right, so now we're gonna talk about last question is triangle inequality. This part is I'm gonna talk about this one. 2 sine square of x minus sine of x minus 1 greater than 0. Okay, so we have talked about equation already. So we have talked about this, but in terms of equation. So let's talk about that first. 2 sine square of x minus sine of x minus 1 is equal to 0. Do you guys know how to solve this?
Something about like something. Show you.
What do you have to do? Okay. Yes. And that's 2 sine of x, and that's sine of x. And this is a 1 and 1. And this is 2 sine of x, and this sine of x. Which one would be negative? Okay, so it'll be 2 sine of x plus 1 times sine of x minus 1 is equal to 0. When does the sine of x is equal to negative 1/2? You should know that. Alex, what is sine of x equal to negative 1/2? When is the sine of x equal to negative 1/2? Oh boy.
That, yeah.
No, not 5 pi over 6.
11 pi over 6.
Yeah, that's fine.
11 pi over 6, and the x equal to what? 7 pi over 6. Okay, so when does sine of x equal to 1? Pi over 2. Is this okay? So this is called a trigonometry inequality. It seems like a quadratic inequality. So then we had to do a number line test. We start at 0 to the next pi over 2 to the next 7 pi over 6 and 11 pi over 6 and then 2 pi. So you had to do a number line test. Now what you need to plug in on a number line test, this is going to be 2 sine of x plus 1, and this is sine of x minus 1. Is that okay? So I'm going to plug in the value here, and what do you think is going to be positive or negative? If I plug in anything between 0 to pi over 2 on the first parenthesis, what am I going to get? Positive, because you're going to have, let's say, pi over 6. 2 sine of pi over 6, 1/2 is 2. So this is positive. Is that okay? What happens if we plug in pi over 6 on sine of x? It's going to be 1/2 minus 1. It's going to be what? Negative. So that's negative. What's a good number to plug in between pi over 2 to 7 pi over 6? Pi. Good. What happened to sine of pi? 2 sine of pi is what? Plus 1. Sine of pi is 0, right? So it's positive. Is that okay? Sine of pi, again, this is negative. It's still negative. You can have two negatives. What's a good number to plug in 7 pi over 6 and 11 pi over 6? 3 pi over 2. Genius. 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 1 times 2 is what? So this is going to be what? Negative, right? And how about this one? Sine of 3 pi over 2 minus 1 is what? Negative, right? So that's positive, right? And then from 11 pi over 6 to 2 pi, well, this one's kind of hard because I'm going to plug in, like, say, 1.99 pi, right? Why is 1.99 pi? Because I can plug in something really close. I know that it's going to be really close to 0, so this is going to be positive. And 1.99 pi, this is probably very close to 0. This is going to be negative, so it's negative.
Where did you get 1.9?
1.99 pi is really close to 2 pi. But we know the value of the height at a sine angle at like almost 2 pi is really close to 0. But so the negative 1 is going to be the one is going to be deciding the sign. The same thing as this positive 1 is going to be deciding the sign. You could. I mean, in this case, probably 2 pi will be fine too. But now let's answer the question. Less than 0. If it's less than 0, which region? 0 to pi over 2. Good. But not including pi over 2 because you plug in pi over 2. If you plug in pi over 2, I think you're going to get 0. But it's not really less than 0. And so pi over 2 to 7 pi over 6. And from 11 pi over 6 to 2 pi. And this is including, this is not including. And this is the answer for this because you had to do a number line test. Because if I were to plug in 2 pi, if I plug in 2 pi here, that's going to be 0. This is 0, minus 1. Minus 1 is less than 0. Because you got to check the endpoint, make sure that they're verified. So this is a number line test. You can have some question about those two, and then overall, it's, you know, it's not difficult. Yes? Yes.